Now we're going to go through some problems that are going to help us prepare for our quiz that's in our next class. So we started this unit by looking at polynomial operations. So we had to add, subtract, and multiply. So adding, we don't really need those parentheses, okay, because adding is a positive number. The positive is not going to change any signs. So I've got 3x to the fourth minus 3x squared plus 5 plus 2x to the fourth plus x squared minus 7. So all I really have to do is combine like terms. Now remember, you want to write your answers with your exponents going in descending order. So I'm going to start with the biggest exponent, which is a 4. So I've got a 3x to the fourth on this side and a 2x to the fourth on this side. That combines to get a 5x to the fourth. Remember, your like terms, same base, same exponent. All right, then I've got a negative 3x squared and a positive x squared. Give me a negative 2x squared. And then I've got a positive 5 and a negative 7 to give me a negative 2. So all I did was combine like terms. Subtracting is very similar, but now I've got a negative 1 in front of my second parentheses. Anytime you have a negative number or any number in front of your parentheses, you have to distribute it. So I need to take this negative 1 and distribute it to everything inside the parentheses. Right? Now this is the same two polynomials from the first example, but now I'm subtracting. So I'm going to bring down the first one, 3x to the fourth minus 3x squared plus 5. Now I'm going to distribute this negative through the second parentheses. So I'm going to have a negative 2x to the fourth, a negative x squared, and a positive 7. Now I'm going to do just like we did with the first one, and I'm going to combine my like terms. So I've got a 3x to the fourth and a negative 2x to the fourth, which is going to give me just x to the fourth. We've got a negative 3x squared and a negative x squared, which is going to give me negative 4x squared. And I've got a positive 5 and a positive 7, which is going to give me a positive 12. So subtracting, first you distribute your negative, and then you do the same thing you did when you added. And the last operation we looked at was multiplication. Okay, remember we have two ways that you can multiply. I don't care which way you choose, just pick one and become a pro at it. Okay, so I'm going to do both. You only have to write down the one that you like. All right, so I'm going to start with FOIL. Remember, FOIL is first, outer, inner, last. And more so than remembering the letters, remember the concept. Okay, so I'm just going to rewrite it. 5x minus 4 times 3x plus 1. Okay, the concept of FOIL is that I'm taking everything in my first parentheses and multiplying it by everything in the second. So I'm going to start with 5x times 3x to get 15x squared, 5x times 1 to get 5x, negative 4 times 3x, negative 12x, and negative 4 times 1, negative 4. Then we just combine our like terms, which the only ones I have are positive 5x and negative 12x. So then I'm going to get 15x squared minus 7x minus 4. So that's all you have to do when you FOIL, or when you, some of you guys call it the rainbow, and just taking everything in the first one, multiplying by everything in the second one. The other method that we looked at is the box method. Okay, so this is a binomial times a binomial. So I've got two terms in each parenthesis, so I'm going to make a 2 by 2 box. And then across one side, I'm going to have 5x and a negative 4. It doesn't matter if you do the top or the bottom. And then along the other side, I'm going to have a 3x and a positive 1. Remember, all I'm doing is finding the area of this box. So I'm going to do that by finding the area of each individual box and adding them all up. So 3x times 5x gives me 15x squared. 3x times negative 4 is negative 12x. 1 times 5x is 5x, and 1 times negative 4 is negative 4. Right? Your like terms, if you have any, will be diagonal. Then I just bring everything down. So I've got 15x squared, 5x, and negative 12x gives me negative 7x and minus 4. All right, so pick one of those methods to multiply and stick with it so you can get really good at it. Then we graphed. We graphed our quadratics. Remember, quadratic, if you have x squared as your biggest exponent, it's a quadratic equation. So it's going to make that U shape, and we call it a parabola. So in standard form, we have ax squared plus bx plus c. Okay, ax squared plus bx plus c. A couple things to remember. Whenever it's in standard form, the first thing you got to find, aside from identifying your a, b, and c, is your axis of symmetry. Okay, our formula is for that is negative b over 2a. Right, and remember, you always write your axis of symmetry as x equals a number, all right, because it's a vertical line. After you find your axis of symmetry, you plug that in to find your vertex, right, because your vertex is on that line, and then you're going to use your y-intercept, which is just c, and reflect it over to get your second and third points. Remember, you have to have 3 points to be able to graph your parabola. Right, so for this example, 3x squared minus 6x plus 2. Okay, my a is 3, b is negative 6, and c is 2. Right, I'm going to start with my axis of symmetry. Right, so negative b would be positive 6 over 2 times 3, which is 6. 6 divided by 6 is 1. Okay, now I can go on my graph to a positive 1 and draw a really crooked dotted line going down. This is the middle of my graph. This is the middle of my U. On this dotted line is going to be where my vertex is. So to find my vertex, I know that the x value is 1. So it's 1 comma something. That something I get by plugging in 1 to my original equation. So 1 squared is 1. 3 times 1 is 3. Right? Negative 6 times 1 is negative 6, and then my plus 2. 3 minus 3 is negative 3, plus 2 is negative 1. So my vertex is at 1, negative 1. All right, the other point I need is my y-intercept. My y-intercept is the c value. So my y-intercept in this case is 0, 2. So I'm going to go to 0, 2 on my y-axis and put a point. To get my last point, I reflect it over. It's 1 away, so I'm going to go 1 on this side and connect to get, oops, missed it, to get my parabola. Right? Then it's asking for the domain and the range. The domain is always all real numbers. So you go negative infinity to positive infinity. The range is depending on the y value of my vertex. So if I look at my graph, I start at my vertex and I go up forever. Right, so that means that my range starts at the y value and it goes to positive infinity. So the y value of my vertex is negative 1. I'm going to put a bracket around negative 1 and a parentheses around my bracket, or my infinity. Parentheses always go around infinities. Graphing in vertex form. Okay, vertex form is a little bit different than standard form. Now instead of A, B, and C, I have A, H, and K. Right, so this H is my horizontal, right, how I'm moving left and right. K is a vertical, up and down. But the biggest thing in vertex form is knowing the vertex, okay, which is going to be at the point HK. Now remember, H is always going to be the opposite sign. Right, the other thing you have to remember is A, which is the same A from standard form. Okay, if it is positive, it opens up, negative opens down, and then if A is greater than 1, all right, if A is greater than 1, it's stretched, so it's getting skinnier. Okay, if it's between 0 and 1, it's getting fatter and it's compressed. All right, so that's important to know whenever you're working in vertex form. So I'm going to graph negative 3 times x plus 1 squared minus 3. All right, so my H is a negative 1, my K is a negative 3, and my A is a negative 3. So my vertex is at negative 1, negative 3. So I can go on my graph, negative 1, negative 3, put a point. Okay, I know that it's supposed to open down, so I can go ahead and sketch what it might look like if it opened down. And then this 3 tells me that it's going to be stretched, so it's going to be skinnier than my sketch over here. So I'm going to draw a solid line that goes in between and is pulled thinner than my sketch for the dotted line. All right, and even though it doesn't say it, we're going to talk about domain and range for this one too. So the domain is all real numbers, And then range, I'm coming from the bottom, from negative infinity, and I'm stopping at my vertex. So I'm going from negative infinity to negative 3 with a bracket.